Hey, hi friends. Hi everyone. Good evening once again. Welcome back to the channel. Today I will be the interviewer and I will be the interviewee as well. Unfortunately, the other colleagues of mine, Nitin and Bharani, will not be able to join us in today's discussion. So I'll be donning both their hats as well, and we will try and talk about text mining today as part of our discussion. And I'll try to frame questions also, and right, I'll try to answer your questions. Um, as you have seen in these series of sessions that we are doing, we are trying to decode each topic and understand what are the core areas of your preparation. What could be the focus of the interviewer? And if you have observed, try and do so. Watch the recorded videos once again, go through the channel. All these videos. And if you observe keenly, you will see that the entire focus was on majorly two things. One is with respect to the project application. So any project that you talk about, what is the business problem that it is solving? That is the focus area for us. Okay. So logically or business standpoint, what is that we are trying to solve? This is the important aspect for a data scientist. To solve this, we were using various techniques, various algorithms, and for implementing that, we are basically using Python programming language as an interface. And in Python, we have readily available packages, functions, right? Packages and functions. And we were focusing on the functions and the respective parameters which can be played around with respect to these functions. These were the two areas that we were focusing. Application part, right? Ultimately, application. So whatever you're learning, how do you apply it? Where do you apply it? What should be your approach so that you should solve the appropriate business problem, right? So try and have these aspects in your preparation as well. Now, today's topic is text mining. Whenever we talk about data analytics, right, always look at the structured data for your analytics. Okay, look out for structured data. And that is the reason why we do all the data pre-processing steps as well, right? And till now, whatever algorithms we were discussing, it is basically done on your cross-sectional data. And we were looking at semi-structured or structured data. In Python, we will do the respective manipulation of this data and ensure that we bring the data into a data frame format. Once the data comes to this format, then yes, you will apply your respective algorithms and change the behavior of that algorithm by altering the parameters. Depending on the time that you have, you will be playing around with these different parameters. But now we are going to talk about unstructured data. Whenever we talk about text, in Python, this is nothing but a string. And strings are always represented in quotes, right? It could be a single quote, double quote, or triple quotes, quotations. In order to process the data, which is unstructured in nature, you need to make sure that the data comes into structured format. And for that reason, we basically split the data into tokens. So unless until you understand what data you're dealing with, you'll not be able to work with it, right? So all this unstructured data that we are getting, which is in textual format, has to be pre-processed, right? Data cleansing. We probably do typo corrections. Typos will be there in the text data. We'll have to ensure that that is corrected. Punctuation marks, special symbols. There may be, right, these additional symbols and all those things which are irrelevant. We also have something called as stop words, or you can say there are certain words which are irrelevant in the context of our project or in the context of your work. We can identify all those words and filter those words from your raw data, right? Your textual data. In Python or in regular practices, the libraries come up with predefined set of words. These set of words are called as stop words. For example, when we try to speak or when we try to write anything, the text data, we generally use these filler words, right? The, and, is, of. These are all examples of your stop words, which are frequently used, and they do not add any value to our text data, right? From a meaning perspective, they don't really give any contextual meaning, the words. So we can eliminate those things as well as part of your cleaning task. Case sensitivity, majority of the algorithms which are developed, right? All those algorithms which run on the tools like Python or R programming language or any other tool or technique that we are using will be always case sensitive. For example, in Python, whatever the libraries that we are dealing with, the Python language itself is a case sensitive language. So you need to have some consistency in your text data when you are analyzing for the information from that. So you need to have conversion. Type conversion is something that we call it as, right? From uppercase to lowercase or proper case, or you might want to convert everything into uppercase, right? Depending on what you're trying to achieve, we can do this case sensitivity. Then we have some advanced techniques like stemming, lemmatization, word sense disambiguation. All these things that we are listing here are used for cleaning the text data. If I talk about a text data, right, it is basically comprising of words, and each word has a meaning. But English, these sentences that are written, you have to understand that these sentences are written using space, right? So any data that you have, text data that you have, first you have to break it down to smaller quantum. And the least quantum that you see in the text data is nothing but a token. Token is nothing but a word. So we'll also do tokenization and converting these words into something called as like structurization, structure format. Right? So tokenization is the process. We can do different tokenization techniques. Character tokenization, word tokenization, n-grams tokenization. So why should I only use text? If you look at this sentence, if I break it down into individual words, then I will get text separate, mining separate, and separate, NLP separate, pipeline separate. Right? So rather than this, why not we have text and mining taken together, two words taken together. If I try and generate two words, then I'll get more meaning, right? Better meaning. So your interviewer would definitely ask this question on what kind of analysis did you perform on textual data? Now you would probably say, hey, we've performed word cloud. That is pretty common thing that we generally do that, right? Word count. So we are taking the unstructured data, trying to structurize it, and then we are generating this word count based on the key and value pair that we generate. But why only single word? Because when you say sentiment analysis using word cloud, don't you think two words will make better sense or better interpretation? Or three words, if you take together, it gives you even better interpretation, isn't it? So we will have to look at the possibilities of generating not just unigram, but you also have to generate bigram or trigram. That means three words taken together. And try to see if you can make better sense of your context if you take bigram or trigram. Going beyond trigram doesn't make sense, friends. Practically, it doesn't make sense. This is also something your interviewer might ask you to understand how practical you are, because we'll never see the words, right, which are probably four words or five words being used together, right? So the word count is the word cloud that is basically defined on word count, right? We're saying count, that is nothing but frequency, right? So how many times each word is repeated, the frequency is captured. Now, how many times do you think a series of four words taken together are repeated? Not many, right? You cannot think of many such words. Single words, yes. Bigram, you still have a lot of um, words which are frequently used. Three words taken together, the number of vocabulary, right? Number of words which are generally used together, three at a time, is little less compared to two words. Four words even comes down. Five words, very much less. So the word count will not give you appropriate information if you go beyond 3 grams, right? Trigram. That is something that you need to look at. You'll also get a question on in what kind of cases I should do TF-IDF. Why not I just take TF, the word count? Why should I go for TF-IDF? Right? This is another question practically that you should be able to readily answer it. You can do all the calculations that you're going to perform on the key and value pair structurized form of data in basically your DTM or TDM. This arrangement is your matrix arrangement of the words and its respective counts. You can directly take the count and perform all the operations that you want. But why should I go for TF-IDF weightage technique is something you need to understand. This is like your normalization. On your cross-sectional data, regular data, operational data, or numeric data, you can say, we generally do normalization to ensure that the scale difference is not there. So TF-IDF is very similar to your normalization concept. Right? So that is something that you need to also understand. So if you see that there is a huge variation in the count with respect to the words, then yes, normalization makes sense. But otherwise, you can directly use the count. The another important point that you need to remember with respect to text data and NLP is that your data is unstructured, hence the processing of the text data is going to be a little computationally heavy. Okay, so you always try and write your code logic in such a way that it uses memory optimally. So memory optimization is something that you have to do. And you always try and use best practices in coding. Code optimization is something that you'll also have to try and do. This way, you will be able to improve your performance, basically the code performance a little. The very, very popular libraries in text mining that you might want to talk about would be NLP itself, right? And let me try and show you the list of those packages here. We'll try and see if this is something I can show. Yeah. Okay, these are all different things that we can perform. This is basically your code and your packages, you can see. The most important package in dealing with text data is the regular expression, RE, which is also called as regex. This is a mandatory library for you to learn, right? There are a lot of formatting techniques for text data. Standard formatters are there. You need to understand the RE package implementation. You'll have to practice on that. Then we have NLTK, which is one of the popular libraries, which is used for doing a lot of cleaning and a lot of applications. For example, here we have dictionaries. From NLTK library, we have a lot of dictionaries that we can use. And using those dictionaries, we will be able to do a lot of functionalities as well. For example, word tokenize. This is basically identifying, detecting the words and splitting them. POS tag. This is basically your grammatical tagging. Now, a lot of people ask me on why do I even need to do POS tagging, parts of speech tagging? Why not directly take the meaning of that word after making the tokenizations, right? So you're tokenizing, you get the tokens. Now, using the tokens, why not we try and generate whatever analysis that you want to analyze? Why we need to do parts of speech tagging? For this, I would probably answer the question in a way saying that, did you learn English directly from letters to words and from words to storytelling? No, right? If you remember your very, very young age days, school kids, you remember English is about letters, then words, then sentences, but in between, we also have grammar. Without understanding the meaning of the text, meaning of the language, you will not be able to interpret the sentences as well. Parts of speech tagging is like your grammar detection, right? I mean, grammar understanding, I should say. Whether a specific token is an adjective, whether a specific token is a verb or a noun, that grammatical tagging will give us a lot of information. And that is what parts of speech tagging does. And it will help us to do a lot of additional things. So it is interlinked. Right? Then we have corpus to eliminate stop words. Tweet tokenizer. These are tokenization techniques. There are many different approaches to do tokenization. When you're trying to split your sentences into words, when you're chopping them, there are many ways. Special characters could be there, spaces could be there, or some other logic that you want to apply. One such logic is very interesting. This one is multi-word tokenizer. So multiple words together are generally treated as single word, right? So those kind of words should be treated as individual word, even though there is a space. So there are certain customizations that you might want to apply when you're dealing with tokenization. The another important question that a lot of people tend to ask is the text mining approach completely different from whatever we are learning as part of data mining techniques? To answer that question, I would say data mining is basically a study which defines many different approaches to process or mine the data. Text form is one form of data only. Text is also data, right? And because text data contains certain characteristics, Depending on those characteristics, you are going to process the text data a little differently with additional concepts, deviated concepts. But ultimately, the logic is to extract meaningful information out of the text data. Okay. And another very important point, I should have started with this. Text mining does not mean only written language. Okay, text mining is generally language mining. This is how I would personally try to see. Because your language can be either written or it could be also spoken, right? We are also speaking. It could be written or spoken. So textual mining basically deals with both text data as well as audio data also. And this is where we get into deep learning, friends. Because whatever the data that you're dealing with, whether it is a text format or whether it is audio format, we are going to ensure that we process that and bring that data into the standard data frame format so that your computer can start processing it, right? So that is very, very important. So NLP or text mining does not only mean text data, written text data, but also audio data. Okay. And we basically don't have a specific order to these steps. Ultimately, we follow the same CRISP MLQ methodology here as well. You understand the business problem and then try to get the data. What data you're dealing with? Here we are saying text data. Post that we do data pre-processing. We have seen the chart, right? I've shown you that when we started our session. There are a series of things that we will do as part of pre-processing. And once the pre-processing is done and once your data is arranged in an appropriate format, that's when we tend to do your actual application, right? There are a number of different applications that you can talk about, like including next word prediction that Gmail does or your mobile applications do. When you're typing something, based on the sequence of steps, the next word is also predicted. It is like conditional probability, very simple logic, conditional probability. Given these previous words in sequence, what could be the probability of the next word? Whichever word has the highest probability, you will be using that word as the next word. This is what is your Gmail or many of the other applications which use analytics do. Right? Sequence, data sequence is basically that's something that we are trying to identify. Sequential pattern mining, you can say. We also use the textual data analytics in various things like your recommender system, recommendation engine, right? Your email processing, document parsing. In fact, your resume parsing, document could be your resume, right? So a lot of job portals, they do analyze the text data that is there in the resumes. And this is one of the reasons we also ensure that we communicate to our students that when you're preparing your resume, ensure that you have the right keywords, appropriate keywords should be there. Because your ATS systems will perform, right, textual mining actually, automatic tracking system of your resumes. They decode the entire text data that is there in the resume into tokens, right? It splits the entire resume into words, keywords, tokens. And then it tries to take the job description and tries to map it with these tokens. Word to word comparison happens, right? So resume content with job description content, we map. And then the ATS system, based on the similarity score, it gives you the ranking on the resumes. It ranks. The resumes which are ranked at the top, they get automatically picked up, friends. Right? So very, very essential to have the right keywords in your resume. Now, having the right keywords is also it's like an art. Your resume creation is also like an art, because your job description could be saying data science. If you don't have this keyword in your resume, then your resume will not get selected. Now, let's say you decided that, okay, I will update my resume with the skill as data science, right? If that is the case, if you're getting a job description with that word, then fine. But what if your job description says DSLO? A lot of job descriptions use shortcuts. They say only DS. You have updated your resume with the term data science, the full form. But if you get the job description like this, for this job description, your resume will not get selected, because you don't have a word called DS. You have a word called data science. So ATS system will not be able to capture your resumes with respect to these these kind of behavior. Right? So what we do? In order to overcome this, if you understand the scenario, the functionality, how the system works, then you will be able to also do better work on your resume, right? This is like you are basically giving the word data science in your resume. Somewhere you fit it, probably in your core objectives, your career path definitions, or you describe about yourself. So you're using the word data science. But at the same time, you also have to use the word DS. This way, both the options are available in your resume, and even for this and for this, both job descriptions, your resume gets selected. So you need to improve your scope in order to ensure that your resume gets selected. Now, this is also text mining, friends. If you understand the text mining concepts better, right, in more detail and thoroughly, then you'll also be able to play around with your resume quality as well, from an interview selection perspective. Okay, so very important, text data mining. We can probably continue discussing on more about text mining, the libraries that we use, the parameters that we have for these text related libraries in our next session. And we're just getting warmed up, friends, in this series. Hope you're learning the right concepts well. Do subscribe, like, share, and leave your constructive feedback for us so that we can improve further, and in turn we can help you achieve your goals. Thank you so much, friends, for today's session, attending today's session. And right, learning is mutual. Thank you so much for helping us learn, and in turn you're also learning. See you all tomorrow. Enjoy the evening, rest of the evening. Thank you so much.